Okay, today we're going to cover topic on transport evaluation, transport project evaluations. Okay, the transport project evaluation, just apart from the transport economic, so we do not cover the total aspect of transportation economics because that is quite a broad topic. Even we can offer one other course if we need, but we don't spend. We do not offer that particular course for transport economic. So we just put a subtopic under transport planning engineering. We focus on transport project evaluation. Okay, first, the aim or the objective project evaluations is to determine technical, economic, financial, environment, feasibility of individual projects. Then to clarify the choice between similar alternative project intend to achieve a stated goal. Okay, the third one, prioritizing project with different immediate goals. So these are the target or the objective. Why we need to evaluate project on transportation. So we're looking at many aspects, many criteria, what our focus or our goal to evaluate that particular project for transportation facilities or system. Okay, economic evaluation technique. So for this particular topic, we're going to use economic analysis to evaluate all the transportation project in terms of the cost, in terms of the maintenance, in terms of the liability. So for this short topic, we're going to cover only two methods, which is it's quite common: life cycle cost analysis and cost benefit analysis. So this is quite typical under economic evaluation or economic analysis. If you taken the engineering economic subject or courses during undergraduate, it's easy to you to understand the application of economic analysis. This one we focus on transportation project. Okay, the first one we look at life cycle cost analysis. The goal of life cycle cost analysis is to account for all the costs of an investment over its entire life. So that's why they use the term of life cycle. Okay, we cover all related costs for the investment. So then we're going to analyze what the value that we're going to input for this particular life cycle cost analysis. Okay, these costs are usually thought of as including initial investment, which is capital or capital cost, and a series of annual costs. So we have to consider this because our project is not for that particular period only. They're going to have a period in terms of the completion of the project, in terms of the operation of the project, that particular transport project, and also the operation. So that's why they include also the cost from maintenance and operation. And also they also include, okay, in case of the transportation facility investment, the annual cost of the user of the facilities are often included as well. So this also the another scope. They include for annual cost. The user that bear the cost for use the facility for the transport. Okay, offsetting this cost is a salvage value of the investment, since there may be additional costs for items such as demolition of structures and removal and disposal of the debris. So of course, they as part of the structure of the waste of and anything, we consider that would be the scrap or the thing that we can put a value in terms of the salvage. That's something you have to consider uh, the cost of activity. We doing some demolition or removal, or we dispose for that scrap of all the remaining the thing from our construction material or construction structures. Okay, the expenditure take place at different times. Thus, it is necessary to consider time value of money, which is expressed by interest rate and discount rate. So we cannot run from the economic. They deal with the time, they deal with the interest that deal from the amount of money. So of course, we're concerned about the time that cost the money itself. Okay, high interest rate indicate a desire for consumption now, as opposed to consumption in the futures. So that's why we really need with the deal the such value. We're going to evaluate, we're going to analyze, because some interest of any capital cost, maintenance cost. So we have to pay, we have to put into consideration. The low interest rate indicate relatively greater desire for consumption in the futures. So it depends the situation. Some in terms of our economy, if we have a good economy in terms of GDP, in terms of a growth rate, so maybe in terms of the payment for our installment or our loan, they might be different. Sometimes during economic crisis, recession, so the interest will be going high. So that's the situation. Okay, costing occurring at different time may be placed on comparable basis by either reducing the future amount of the present value. Okay, I just bold the present value. Okay, by calculating the equivalent annual cost of the investment. So we have to know the present value, what the amount that we put for the investment. By that, so we know what the amount for the equivalent annual cost of investment. So the present value and amount, some they put the C, okay, symbol, and also they put N. Okay, year in future is given by, so we can predict the value present that we have to spend for the future value. So by putting the amount from present and future value, and put the interest rate. So here they put R, refer to interest rate, and N refer to years that we going to complete for our loan or our target, to spend. Thus, the total present value of investment is given by, okay, this they put all the costs to consider to sum up the present value investment. Okay, the first one in initial investment. So the C is represent the annual cost. And S is salvage. So we have discussed before the salvage, and N the life of the project. Okay, if annual costs are same, the total present value is, so we can combine some uh, cost with using this particular formula. Okay, where CA is the annual cost, as capital recovery factor, so they put as CRF, so as CRF. Okay, and interest rate R and period of N. Okay, the capital recovery factor. So here they put CRF. So the detail for CRF, capital recovery factor, to be like this. Okay, they have interest rate and also number of the years. So the CRF is factor that when multiplied by amount of investment at present, give the value of equal payment made at the end of each succeeding year over the life of investment. Okay, don't worry, because in terms of explanation, they're going to look quite complex. It's not easy to understand. Okay, we're going to cover for the example to look the practical or the real project to apply this kind of the formula or the kind of the relationship. Okay, initial investment and salvage value may be converted into equivalent annual cost. So the total equivalent annual cost, so we have here, so represent A. So we have I represent for initial investment, S is salvage, shall F is annual cost, and also the S is salvage. So here we have total equivalent annual cost. So note, normally equivalent annual cost will be calculated only where the annual costs are known. So it can be assumed to be uniform. Okay, let's start or look at this example. Okay, read the example properly. So there is a lot of the numbers or information that we're going to identify which represent which kind of the cost. Okay, a proposed new bus route is expected to require 8 new buses to operate a total of 560,000 vehicle kilometers, so this VKT, per year, and 29,000 vehicle hours for per year, so as well. Okay, buses cost ringgit Malaysia 200,000 each, have a 10-year life and a salvage value after 10 years, which is ringgit Malaysia 25,000 each. Operating costs include labor costs, so combined wage, benefit, etc. at ringgit Malaysia 45 per vehicle hours. Maintenance costs at ringgit Malaysia 0.16 per vehicle kilometer, and the cost of fuel, oil, tires, etc. at RM 0.38 per vehicle kilometers. Okay, the questions. Calculate life cycle cost, which is present value, of adding this route and operating it for 10 years, assuming an annual interest rate of 7.5%. So we have many value here. So we have identify which value to be under which cost. Okay, this is the solution. Okay, first we put capital cost. So we have 8 buses which is the value of buses is 200,000 Malaysian ringgit. So altogether 1.600 million. Annual operating costs. So we have a labor, we have a maintenance, and etc. So we have for the labor 45 Malaysian ringgit. So for the vehicle hour 29,000. So here we have 1,305,000. Okay, thousand. And maintenance 60 cent, 60 cent. Okay, multiplied by VKT, which is 560,000. So total of 89,600. Others 38 cents multiplied by the VKT, and the total of others cost is 212,800. Okay, the total we combine all together, so we obtain the value of total cost is 1,607,400. Okay, the salvage. Okay, the negative value. Okay, we have also the salvage value, because the bus would be they have second-hand value. So after 10 years, of course, the value of the bus is going to be decreased. Okay, they putting the salvage value of each bus is 25,000. Okay, multiplied by 8 total bus is, so we have 200,000. So look at, we have a capital cost, annual operating cost, and salvage value. Okay, now we calculate capital recovery cost. So we have a rate of 7.5. So we convert into decimal 0.75. So we have a project for 10 years. So we put all together. So if you refer the economic schedule, they have this kind of the table. So you don't need to calculate if we have the list of the table. So all the calculation for the interest rate for each category, actually they have a table, like a statistical table as well. We have the value of significant, how many percent of significant, 5%, 10%, like that. So economic analysis as well, they have a certain or special table. So, but this one we have calculate because we have the formula. We don't supply the table for the determine the value for this particular rate, interest rate. So we can just proceed the calculation. So we obtain CRF is 0.1457. So bear in mind, in calculation for value interest rate, all the criteria, so we have to consistent using 4-digit numbers. So for engineering, we typically looking at 3-digit numbers. You calculate something in meter, in millimeter as well. So we're looking at 3-digit, but for economic analysis, we look at 4-digit numbers. So please remain in 4-digit numbers. Okay, so now we can calculate the present value. So present value. So we have I, initial investment. So this one missing one zero. Okay, 1.6 million. Okay, missing 1 0. Okay, this we just calculate previously. So this is the rate, the new rate, and this is the salvage from the 8 buses. Okay, the rate for interest. Okay, now we have present value at 12,700,000 something. Okay. Next, we move to cost benefit analysis. Okay, cost benefit analysis is comprehensive method for evaluating economic decision. So we put in cost to construct or to prepare any project. So we also to take aspect of the benefit. So that's why they use this method to identify whether when we put any investment, so we spend the cost, we put the cost to any project. So what would be the benefit from the project? So that's why they use this kind of method analysis, cost benefit cost analysis. So it's compare the capital and operating costs incurred by the provider of service with each benefit, which include the revenue received by the provider, consumer surplus or value of the service to the users, extra benefit or disbenefit to non-users. So they also looking into this particular benefit. Okay, the benefit may be compared to the cost by reducing benefit and cost to a common time base and compare them either as differences or as a ratio. So we have the threshold, or we have to set. Okay, we have certain value to be compared. So typically for ratio cost benefit cost analysis, we put 1 is the threshold, whether the value is under 1 or over 1.0. That particular threshold we're looking at to determine whether that particular project giving good benefit or less. Okay, in the net present value method, so cost benefit are both reduced to present value and the net present value is calculated. So this is quite common to you, NPV. So we have a benefit and deduct the cost. So benefit is represent present value of the benefit. Then the cost is represent the value of the cost. So we need to compare this thing. Okay, what are the difference? Okay, and then this is our ultimate. In the benefit cost analysis, we look at ratio. So benefit cost ratio method. Cost and benefit are either reduced to present values or annualized and compare as a ratio. So we looking at this kind of the comparing benefit value or benefit outcome to compare with the cost that we put. So this the very common and simple, the simple way. Okay, then we put the threshold as to trigger whether it's under or over. Okay, rational investment policy may then is expressed in terms of set of decision rules. Feasible rules, okay, no investment should be undertaken unless the total benefit exceed the total cost. This is the practical, the implication of practical we have to consider. Yeah, we put some amount of the cost and we look at the outcome of that particular project should be give a benefit. And that's why if we put something to funding to the project, but if there is no benefit or give some good in terms of the revenue, so why we do investment? We put the risk to our project activity or transport project. Okay, now we look at this scenario. Okay, the first one, if we use net present value, so make sure The B, that benefit, we can calculate it. So we can put many in terms of a rate or to represent value. So we deduct from the cost. If the value, okay, the value over 0, okay, consider it going to be a benefit. Or if we use ratio, okay, we compare benefit over the cost. Also, we looking at the ratio. The threshold is 1.0, is over 1.0. Consider that particular project will be benefit. Okay, okay, where the budget are constrained, alternative investment are ranked by NPV or R. So we can use either one. But quite common one, we use this one. Okay, those with the highest value are selected in order until the budget is adjusted. Okay, scale rules. Investment whose scale is continuous variable and whose net benefit decline with increased scale should be sized to the change in the benefit and increase of 1 unit output equal to change of cost. So this one they just put a scenario by theoretically. So we do the called differential. Differential. So the Q is the output of a project. Output of project. So we compare from the benefit and the cost. Also, we look at the threshold of 1. Okay, where the budget constraint preclude satisfaction of DB over DC. Okay, one. Or alternative investment should be made at scale such. We have A, that a constant selected adjust the budget. Where the scale of investment are not continuously variable, alternative project design are ranked in increasing order of the initial cost. Each alternative is compared with the next larger one. Of course, we're looking at the value higher would give a benefit or to be selected. Okay, so long as the incremental benefit increase, the incremental cost and the larger scale project is chosen. So that's why even we spend more money for invest, but if we have a more benefit in terms of output outcome, yes, it will be considered to step particular projects. Okay, look at this particular example. Okay, capital cost of a rural highway project is 10 million ringgit. This project will be shortened by road, the road by 2 kilometer, and reduce journey by average of 5 minutes each. Okay, this project is also expected to reduce traffic accidents by an average of 5 per year and reduce annual maintenance of costs by 5,000 ringgit. Average daily traffic on this road is currently 7,000 with a load factor of 1.5% per vehicle. Traffic is expected to grow linearly by 10% over the 20-year life of the project. Okay, look at this particular question or statement. So we have a cost here, capital cost, 10 million. Okay, to funding this project. The project to construct, I think, bypass road. Bypass road. That will give a benefit to short time for travels. Okay, looking at this capital cost. Okay, so we consider this would be our C. Okay, then the rest would be the benefit. So this one is the first one, reduce the travel times. Okay, also reduce the accidents. Okay, which can translate the numbers average of 5 years, and also reduce in terms of the maintenance 5,000. Okay, also can commute about 7,000 7,000 daily trip. Okay, and this project expected grows linear over 10% life of the project in 20 years. Okay, okay. The question: if vehicle operating costs are 10 cent, okay, 10 cent per kilometer, traveler values their time at 3 ringgits each hour or per hour, and the average cost of the traffic accident is 20,000 ringgit. What is the what is the benefit cost ratio? Okay, assume an interest rate at 5%. So for the particular question, so it is not very straightforward. Very straightforward. We can use one single formula and answer all everything in the one simple solution. So we have to consider the repetition first. Okay, the first we going to calculate the benefit because we have a lot of the kind category of benefit. The first one we look at the reduction of the time for journey or the trip. So we have shortened the period within 5 minutes. So did we build to compare within 1 hour? So the spend we have to spend 3 ringgit for every hour with the average people 1.5 per trip, and the length is 2 kilometer, and the cost also 10 cent. So here we get the numbers. Okay, then we have the first value for a benefit per trips 0.575 ringgit Malaysia. Okay, the next benefit we call B2. Okay, or we can combine the reduction of accident and also the cost of maintenance. So annual benefit from both factor. Okay, the accident we can consider. Okay, we have 5 accident in a year we can reduce, which is the value is translating into 20,000, and also the maintenance. Okay, 5,000. So this one is 100,000 plus 5,000. So we have 105,000. Okay, the trip in the base year. So we have 7,000 trips. Okay, a day. So in a year, so we have okay, of course, 365 days in a year. So we have total in a year about 2,555,000 trip. Okay, the total benefit. Okay, the traffic grows at 10% over 20 years. Okay, therefore annual traffic growth. So we put 0.1 for represent 1% over 20 years. So we get the growth, the great growth. For annual is 0.005, which is quite small. Okay, okay, we calculate for first year. So we have to do the repetition during the first year. So we have annual trip that we have calculated previous slide. Okay, so we input the new rate we have calculated, this one, and the first year of year one. Okay, we obtain this value. Okay, annual benefit, we combine the rate that we calculated and also the cost of accident and maintenance. So we obtain this annual benefit. So discounted benefit. So because they put the rate of the 8%, okay, 8% of interest rate. So we consider this rate, okay. That's why we put discounted rupee. Okay, we have interest rates of at 8%. So we obtain the discounted benefit at 1,400,000 something, 400,000. Okay, now we have to do the repetition of the calculations. So we start to give example at year 1. So we have 5%, no 5%, less than 5%, 0.05. Okay, then we repeat the increment of every year. Okay, year 1, year 10 until year 20. Because this project is live for the 20 years. So we repeating doing the calculation to calculate the dose benefit, trip benefit, okay, and so on. Okay, until we finish at the year 20. Okay, we obtain the total amount that we counted altogether is 16 million. 16 million, okay, something like 16 million, 64,619. Okay, now we obtain two value to be compared. So just remember, so we put how much in terms of our capital cost. Could you recap? How much? 10 million. We put our capital cost is 10 million. Okay, you can refer the slide. Okay, now we want to do the comparison. We use ratio, cost benefit ratio. Okay, now we put the total cost of the benefit we just calculated previously. This one, 16,000 something, 16 million something. So comparing to 10 million of the capital cost. Now we obtain 1.6. So what is our conclusion? So this project will be benefit. So it is worth it to spend this particular project. So I think that's all to cover our session today.